record this, and it is recording. All right, good morning. All right, so I will go over the one request I have about the calculating the payment for Knapsack auction, and then I'll go over some interesting stuff about the what we call the VCG mechanism, and another way of interpreting the payment rule for a DSIC thing. All right, so let's jump into a Knapsack auction example. Okay, so for the Knapsack auction, remember that it is not a it is not efficiently implemented for the offer maximization. So we have an approximation algorithm for it. So the approximation algorithm is fairly straightforward. It will rank everything from in according to its density. Right, so rank objects in value density, and start picking from the largest densities. Start picking ones from the largest densities until we cannot fill the bag anymore. With the bag, with the next one, unless the next one has higher value than all the previous ones combined. The next one has higher value than the previous ones combined, the previous items combined. In which case, we just pick this one only. Okay, so that is the approximation algorithm for offer maximization. And we have said that this is as good as at least one half the best possible solution. Okay, at most twice the best possible solution. Okay, so at most, anyway. All right. And when we determine the payment rule, there is essentially just one jump in the payments, right? So you either get 0 or 1. So what this does is we look for the point, the value point at which a player is selected or not selected. Okay, so there's you look at a player and see varying its values, varying its bids. At which point does it go from being selected in the algorithm to being unselected from the algorithm, or vice versa? And that is the payment. So that is the payment for this player. Okay. All right. So what I will do is just give a fairly random example. I'll make an example right now, and we will just go over this. Okay, so let's try to have this example here. Okay, so 1, 2, 3, 4. Let's have 5 of these. They have the capacities. 3, 2, 5, 4, 1. Okay, and we have the value densities. Let's say 10, 9, 8, 6, 4. Okay, so there we go. So then the value here is then 30, 18, 40, 24, and 4. And let's say our our size of the bag is 10. Is that let's say 9. Okay, that makes it slightly more interesting. Or maybe not, who knows? Okay. All right. Okay. All right. So the algorithm sorts everything in order from value density. So look at the first one and say this one has size 3, so we will pick it because we can fit 3 into our bag. The next one, oops, the next one has size 2, and we now have 5, and we can still pick it, so we can put it in our bag. And the next one is 5, and that is not does not fit into our bag, so we can't pick it. Okay, so in this case, the algorithm will pick 1 and 2. Oh, I guess we should also say that it doesn't pick 3, but looking at the value of this, which is 40, it's less than or equal to 30 plus 18, so it will stop there. Okay. All right. Okay. All right. So we then had to determine the payments for 1 and 2. All right. So let's start with payment for player 1. For 1. Okay. All right. If we were to do a binary search type things, we would say let's we start with 30 and maybe end with 0, and then maybe we go halfway to 15 to see if the algorithm picks player 1. If it's 15, right? In this case, if it's 15, then it has value density that is 5, which is over there. Okay, and definitely not going to do that. Okay, and then you go from 30 and 15, and maybe something in between, 23, something like that. So 7.5, somewhere in here, and it will still not pick player 1. And you just keep on going binary search wise to find the exact payment for player 1. Okay, right. In this case, we will just start lowering the value for player 1 until at which point we know that the algorithm will not pick player 1 anymore. Okay, so if it lowers down so that it goes here in between 2 and 3, right? So if it goes lower down to between 2 and 3, it will still pick it, right? So because there's 2 and then 3, so it will pick that. Okay, but if it goes down to somewhere between 3 and 4, right? So if it is density 8 or less, then the algorithm will pick 2 and 5, and then look at 3 and say that's too much, so we can't pick it. Okay, so and then at that time the value of this is going to be less than, well, the density be less than 8, so that's going to be 24, definitely not greater than 18 plus 40. Okay, so that is the payment. So that's going to be where it goes for player 1. So here for player 1, algorithm will stop picking player 1 when its value density is less than 8. Okay, right, so it goes down to something below 8, then that is when the algorithm will stop picking 1. Okay, so then that means that the inflection point, the point where it differs, is when player 1 has value density 8. Right, so then payment is 8 times the size of the player 1's thing, so that's going to be 24. Okay, all right, so that is for player 1. Hopefully I'm not making any mistakes. It should be okay. All right. Okay. All right. Okay. Payment for player 2 is similar. So if you try to reduce the value of player 2, it will start with 3, and then the algorithm will pick 3, and then it will pick. So if it goes down, if the value density here goes down to 8 or below, it will pick number 3. Okay, and then it will stop. It will not pick number 2 anymore if it goes down to 8 or below. Okay, so payment for 2 is similar. The payment for 2 will just be value density 8 times its size, and that's 16. Okay, all right. Hopefully I did not make any mistake here. Okay. Okay. All right. Okay, so I'll just quickly change this slightly, and we will do this with the slightly different number. So maybe I'll change the 5 here so that it is 7. So that's 56. Okay, so we now change the number 3 so that it's 56. Okay, all right. So RT is still 9. So the algorithm this time, okay, so it will still pick number 1 and number 2, and it stops at number 3, right, because that will give you more than 9. But at this point, you see that 56 is greater than 30 and 18 combined. So the algorithm picks only 3. And so the algorithm picks only 3. Okay. All right. All right, so now we have to figure out what is the payment for 3. Okay, so what is the payment for 3? Right. So we were looking for the point at which the algorithm will stop picking player 3 in this case. Okay. Right, so there are a couple of reasons why it might stop at player 3. Maybe the value density goes down below 6, or the value here is actually lower than the previous values combined, which is 48. Right. So that seems more likely. So let's see if that's possible. All right. So when the value goes down to 48, what is this density? 48 divided by 7. What is that? 6.8 something. Okay. All right. So when this value here goes down to 48, at which point the algorithm will not pick number 3 anymore, right? Because it's too large and the value is not enough. Okay. Okay. And at that point, the density is 6.8. So it's still ranked number 3 in the ranking here. Right? So that is pretty much where it goes, right? So payment for 3. When value goes down to 48, the algorithm will not pick 3 anymore. Okay, so the value density at that point is 48 divided by 7, which is about 6.8, 6.9. Nice. Okay. All right. So at this point, we will say then the payment here is just 48. So at 48 is a point where above 48, the algorithm will pick 3, but below 48, the algorithm will not pick 3. Right, so that is when that happens. All right. Okay. All right. So that is the Knapsack example. Hopefully that is okay. That took a lot less time than I thought. Maybe I went too quickly. It's okay. It's fine. All right. All right, so hopefully that can be generalized to any example. All right. So what I will do now is looking at something called a VCG mechanism. Okay. It's a little bit different. Right? So something a little bit different. Okay. And the idea of the VCG mechanism is we want to look at the payment rule from a different angle and actually generalize it to other auctions, right? So I'm going to generalize this to auctions in a very generic sense. And then we will see what is the appropriate payment rule for which this will always give us a DSIC mechanism. Okay. All right. So we will be looking at payment rules from a different angle. Okay. All right. Okay. So let's look at the two examples we have from class about the single item auction and the sponsored search auction. Right, so let's look at the single item option, the single item auction. Okay. Okay. All right. So in a single item auction, the payment rule that's DSIC is the second price rule. Right. So we have the second price rule. That is, the winner is the one who bids the most, but they pay the second price. Okay. Right. But what is the meaning of the second price? Okay, so why is this important? Okay. So here is one possible interpretation of the second price. What is the importance of having of this number second price? Okay, so what we will do is look at a player and see how much is the total value received by the entire group of players, subject to whether it is bidding or not bidding. Okay, so for a player I, we look at total values and this is important because this is values and not utility. Total values received by all players, all other players, I should say. Right. So we look at the total values received by all other players in two auctions. In the auctions when player I participates and when player I abstains from the auction. Okay, so we are looking at two auctions. One auction has player I in it, the other auction has player I not in it. Okay, and we are looking for the total values received by the other players when player I participates or abstains. Okay. All right. Okay, so there are two cases here. Okay, so the two cases, if player I does not win the regular auction, does not win when they participate, okay. Okay, so when player I does not win when they participate, then that means that somebody bid higher. Right? Somebody bid higher. Right? So someone bids higher. So the total value received by the other players is basically what the player won. Right? So the highest valued player the player who bid the most, right? So they get the most value. Okay, so they get the total value is the one from the highest bidder. Okay, so you have an auction, a normal auction. Normally, the highest player wins. Okay, so when player one does not win when they participate, the total value is received by the other players is equal to the one from the highest bidder. Okay. Okay. But what if player I does not participate in the auction? Right? So you take the auction and remove player one from it and run the auction again. Okay. Well, player I has lower value, lower bid than the highest player, so nothing changes. Right. So the total value is still the same. As if player I abstains from the auction. Then the same player wins, and the value is exactly the same. And the total value obtained is exactly the same. Okay. Right, so this is the slightly more trivial case. Right, so in the single item auction, if a player does not win when they participate, then the result is the same regardless of whether the player participates or not participate. Okay, so the difference is the zero. Right, so the difference in total value is zero, and this is just happens to be player I's payment. Okay, so they didn't win, so they paid zero. Okay, so this is what happens. And so when player I does not win when they participate, the highest bidder wins. Same thing if player I does not participate. Okay, so that is the first case. Okay. Okay. All right. So the more interesting case is when player I does participate and win. Right? So if player I wins, okay. Okay. So suppose that the player I wins. Okay. Then they are the only one who gets the item. Right. So they are the only ones who get any value out of it. Okay. So the total value received by the other players is zero. Okay, so if player one wins, then the total value received by the other players is zero. Right? So because player one takes all the values out of this auction. Right? So all the other players get zero. Okay. So this is when player I does win the auction. Right? So the total value received by the other players is zero. But what if player I now abstains from the auction? Okay, so if player I abstains from the auction, originally player I wins, but now let's say player I doesn't participate anymore. So now it's going to abstain from the auction. Okay. Then what happens to the auction? Okay. Somebody is still going to win, right? So somebody is still going to win the auction when player I is not in there. Okay. And that person who wins is the one who bids the highest among the rest of the player. Right? So the player who bids the highest with the rest of the player is going to win the auction. Okay, so then the player who bids highest among the rest of them wins the auction. Okay, so the player who bids the highest among the rest will win the auction. Okay. Okay. So the value that is received by the other players would be, well, it will be the value of the bid of the player who bids the highest among the rest. So player I abstains. The value received by the other players when they run the auction is is from the one player who bids the highest amongst the rest. And that just happens to be, well, among all the players, including player I, this player actually bid the second highest. Okay, so this player bids the second highest in the original auction. Okay, so this player bids the second highest in the original auction. Okay, so because player I is the highest, and this player is the second highest. Okay, so the total value received by other players is this second highest bid. Okay. So when player I abstains from the auction, the rest of the players will receive a total value that is equal to the second highest bid. Okay. So originally, if player I participates, the other players receive value 0. But if player I abstains, the other players receive the total of the second highest bid. So the difference is the second highest bid, and that is also player I's payment. Okay. So the difference in total value is the second highest bid and this is also player I's payment. Okay, right. In the second price auction, that is the payment for player I if they win. Okay. Okay. So that's a really long explanation for the single item auction in a different way of looking at things. What we are looking at here is essentially the payment for a player is the amount of value that is lost by the other player when it participates. Okay, right. So in this case, when player I participates, the other players get 0. If player I does not participate, the other players get second highest bid. So this amount, the second amount highest bid, is lost when player I participates. And that is the payment for player I. Okay. All right. So that is essentially what the VCG mechanism is going to do for a general auction. It is going to look at the value that is lost by the other players when a player participates. Okay. And that is going to be a payment rule that is always going to be DSIC. All right. All right. So that is the punchline for the VCG mechanism, which I'll describe, which I will write down later. Okay. All right. Okay. So All right, so let's look at the sponsor search auction and see if we can give a similar interpretation. Okay. All right. So we'll just look at the graph here. Okay. All right, so we'll just look at the graph for the allocation for sponsor search auction. All right, so maybe the graph will look like this. At some point, it will jump up. Etc. Etc. Okay. All right. And let's say this is alpha k minus 1, alpha k, right? So these are the click-through rates, right? So this is the higher the click-through rate, the better it is. Okay. Okay. And this is where this is the bk minus 1 and bk. Okay. All right. So in the sponsor search auction, the player who bid the kth highest, k minus 1 highest, will get a alpha k minus 1. The player who bids k highest will get alpha k, etc., etc. Okay. 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 And if you remember, the payment for this is the area to the left of things. Okay. So, yeah. So if you bid something, then the So if you bid something, then the payment is any area to the left of the curve. Okay. All right. Okay. So now this is the regular the allocation graph. Right? So the higher you bid, the more you get. Okay. So what we will look at is, suppose I have a player that enters the auction, and we will see how much value is lost by people who bid. Okay. Right. So when a new player enters the auction, let's say with say B star. Okay, how much value is lost? Okay, all right. Okay, all right. Okay, so we want to see if somebody enters the auction, how much value is lost. And let's say the player enters here. Okay, so let's say B star is here. Okay. Okay, so let's say B star is here. All right. Okay. All right. So if you look at the ranking of all the bids, right? So from B1 all the way down to BK, anything above it, right? So anything that's any player that bids above it, they don't change anything, right? So without B star and with B star, right? Because B star is less than anything above, the allocations for anything above do not change, so they get the same value. Okay, all right. So any bid above B star do not change value, do not change their value received. Okay. So any bid that is above B star do not change the value received. Okay. The problem is with these two, right? BK minus 1 and BK. Right? So we now have one extra bid that's higher than them, B star in this case. So they get bumped down, right? So they get bumped down, right? So in this case, player with BK minus 1 originally received alpha k minus 1, but now they receive a value of alpha k. And so they get bumped down from alpha k minus 1 to alpha k. Okay. So the value lost is for BK is going to be bk minus 1 times alpha k minus 1 minus alpha k. Okay, and that is bk minus 1 times the difference between the two. So it is actually this area here. Okay. Right. So for the player who bid bk minus 1, the value lost is that area. Okay, so bk minus 1 is this size, and alpha k minus 1 minus alpha k is this. So it is precisely this rectangle. Okay. And the player with B who bid bk will go from alpha k to 0. So they lost bk times alpha k. Right, so bk times alpha k, and that is precisely this area here. Okay. All right. All right. Okay, so the value that is lost by all the players, basically these two players, is precisely the payment for the player who entered with B star. Okay, so that is this area here, this area to the left of B star. Okay, so this is precisely the payment for the bid B star. All right. Okay. All right. So this is the general idea, and the payment for a player is the amount that is lost, the amount of values that is lost by the other players. All right. Okay. And this is the VCG mechanism, right? So this is the Vickery, Clark, Groves mechanism. Okay. All right. So this is the mechanism. We will generalize this mechanism to general auctions. Okay. But the idea is the payment for where the payment that is equal to the total value lost by the remaining players when one enters the auction is DSSC. Right? It is the this payment rule is the one that will be the one that is the dominant strategy incentive compatible one. Okay. All right. Okay. Is DSIC? I guess I'll mention a little bit slightly higher, so slightly more. DSIC that is welfare maximizing. That is welfare maximizing. Okay. All right, so that is the VCG algorithm, VCG mechanism. Okay. Okay. And this applies to general auctions as well, not just the one item auction or several item auctions or the single environment that we have. Right, so this applies to general auctions as well. So in a general auction, you have n players. Okay, and you have a finite set of outcomes. And we'll say this is omega. Okay. So we abstracted the outcomes of an auction to something like this giant big Greek letter. Okay, and this could be any number of items. This could be any auction, and these are the all possible outcomes for the auction. Okay. And each player I has a private valuation for each of the outcomes. Okay, so the idea is you have these are all possible outcomes, and each player will look at this outcome and say, well, what is my value if this outcome occurs? Okay, so in the single item auction, the outcomes will be all possible cases where a single player wins. Okay, and every player will look at those outcomes and see what is their valuations for that outcome. If they win, they get their values. So their valuation will just be their own value. If they don't win, then their valuation of that outcome is just 0. Okay. All right. Okay. So that's a general set of auctions. Okay. Okay. All right. And we assume allocation is welfare maximizing. Okay, so essentially what we have here is we have the x of b. So if you look at the bits, right, so we have bits from each player. This is, you look at the maximum possible among all the outcomes. You look for the sum of the value of the outcome. Okay, I from 1 to n. Right, so this is take for each outcome. W, we look at the sum of values received by all players and pick the one that is the highest. Okay. Right. So assuming that the allocation, so this is a welfare maximizing outcome, right? So we look at for each outcome, we take a look at the values received by all players, and we pick the maximum one of them. Okay. Then the payment rule, that is, we look at the what happens for auctions when player I is not in the auction. Okay, so if you look at the value received by all the other players, the maximum possible value received by all the other players when player I is not in the auction, minus the maximum value received by what happens when it is in the auction. Okay. Okay. Then that is the payment rule is DSIC. Okay. So there's a lot of notation here, but it's not that important. But this is what happens when player I is not in the auction, and we're looking at max value received by other players. Subtract value received by other players when player I is in the auction. And we picked this one as the best outcome, as the best outcome. Okay. So then this payment rule is the DSIC one. This looks a little bit too dense, but the idea is just the previous idea we have. The payment rule is basically the value that is lost by other players when we enter the auction, right? So compare the auction when we enter and when we don't enter, and the value that is lost by the other players, that is our payment rule. And this is the one that is DSIC. All right. Whew, okay, so all right. So yeah, so we are now done for all the tutorials. Okay, so thank you very much for coming for the entire term. And hopefully we'll see you again soon. All right, and I'll stop the recording. How do I stop recording?